Hello everyone, I'm Sai. I'm back with another topic called modulation. So today in this video we are going to discuss about the index modulation and the percentage of modulation. These topics are mainly related to the signals, and I'm assuming that you know the information about the signals. So before going into this video, please make sure you hit the subscribe and like button. So let's dive into the topic. So before going into the main topic, let's discuss about the what is a modulation. So before reading this textbook definition, I just want to say that modulation is a process where you vary the carrier signal according to the modulating signal, and where we uh, mainly use this modulation to encode the message signal, which contains some data or information onto a carrier signal, which which makes the transformation easily and suitable from source to destination. And for example, we use in the radio waves, optical fiber, or any other communication channel, as you have seen in the landline phone, where we do a only one-to-one communication. So like that, we have a modulation here. So modulation is the process of varying a carrier signal in order to transmit the information from source to destination. And this variation can be in amplitude, frequency, or a phase of the carrier waves. The primary purpose of modulation is to encode the message signal which contains the information onto a carrier signal, making it suitable for transmission over a medium such as radio, wave, optical fiber, or any other communication channel. Like as we have seen in landline phone, where we use only a one cable to do the communication, and it should be a direct communication. And nowadays we are using optical fiber, which is expensive nowadays. So, so now what is modulation index? So modulation index, also called as a modulation depth, is a measure of the extent of modulation applied to a carrier signal. It indicates how much the modulated parameter of the carrier signal varies from its unmodulated level. The modulation index is different from various type of modulation. So basically, it means that it tells them how much it got varied, how much the carrier signal is got varied according to the modulating signal. And when the information is transferred into a signal or in a wave form, it's known as a modulating signal, and get varied according to the modulating signal. So we have three types of modulation: amplitude modulation, frequency modulation, and phase modulation. So in amplitude modulation, this modulation is defined as AM, and M is equal to AM and divided by ACM. And we will discuss about this unit and this formula in next step. So frequency modulation is defined as beta is equal to delta F by Fm, and phase modulation is known as a peak phase deviation. We represented as a delta theta, where M is equal to delta theta. So what is amplitude modulation? In amplitude modulation, the modulation index is defined as M is equal to AM by ACM, where AM is the peak amplitude. Like as you know, we have like wave as like this curve and all, and the peak that we known as AM uh, of the message, and AC is known as the peak amplitude of the carrier signal. So, for example, if the peak amplitude of the message signal is 5 volt and the peak amplitude of the carrier signal is 10 volt, then the modulation index will be 5 divided by 10, which will be 0.5. As you can see on the screen, like at the end, we have a 0.5. So this is known as amplitude modulation, or we can say, in other words, like amplitude index. Yeah. Now frequency modulation. So it is defined as beta is equal to delta F by Fm, where delta F is the peak frequency deviation and Fm is the maximum modulating signal frequency. If peak frequency deviation is 75 kilohertz and the maximum modulating frequency is 15 kilohertz, the modulation index will be beta is equal to 75 divided by 15, which is 5. Now you're wondering about the modulation waveform. So modulation waveform, when we combine the message waveform and the carrier waveform, then it will give a final product, which is known as a modulating waveform. And that's known as a modulating, or we can say modulating waveform or modulated waveform. Yeah. Next, last one, we have a phase modulation. In phase modulation, the modulation index defined as MP is equal to delta theta, where delta theta is a maximum phase deviation in radians. Example, if the if peak phase deviation is 1 radian, the modulation index is 1. Uh, say, let's take one waveform here. Think that this is a message waveform which get combined with the carrier signal, and carrier signal should be higher than in every uh, in every uh, in every field. It should be higher, like in amplitude, in frequency, or in phase. My drawing is very bad. So this is a message signal and this is a carrier signal. So when they combine to each other, then it will form another signal where we can take it as like this. So this is known as modulation waveform. So this is known as amplitude, and this one cycle is frequency, and this is known as phase. So this is the basic information that I want to share. So that's all. Okay. So now we have completed about the index modulation. Let's go to the percentage modulation. The percentage of the modulation in amplitude modulation can be calculated using the modulation index. The modulation index is given by M, where we use all the formula of the amplitude modulation, phase modulation, frequency modulation. So after calculating that, we will multiply that with the 100, which will give the percentage of the modulation. Like as you can see on the screen, where they have given the amplitude index modulation of amplitude, where AM is the peak amplitude of the message and AC is the peak amplitude of the carrier signal. And the percentage of the modulation given by M, uh, which is AM by ACM. And when we get the answer, we will calculate with the 100, then we will get the percentage of the modulation. So that's all for today, guys. And thank you for watching till here. I don't expect that you would have watched till here. So thank you.